No stone unturned.
I'm getting a f***ing cold tooth. And my wife is like, no, you are not. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Tom Nardi.
This is episode 249, Data by Laser and Parachute, Bluetooth hacks, and Google's Gotta Google. This week in the news, we have some cool Hackaday news. We picked up the Floss Weekly podcast, and this is free, libre, and open source software weekly podcast. They are in weekly episode number 762. Previously, it was hosted on This Week in Tech. It's been running for a long time, previously headed by Doc Searles, but our own Jonathan Bennett was one of the other rotating hosts over there. And when they wrapped it down on This Week in Tech, Jonathan was like, hey, can we take this and keep it running? And hey, Hackaday, will you host us? And we're like, let's see, sure.
Yeah, that is exactly the response. It's like, I think we can do that. We're doing one podcast. What's two podcasts, right?
Yeah. So
what's two podcasts between friends?
The Hackaday podcast, of course, we tend to be super hardware-y, although we touch on the software from time to time. But if you want your open source software fix, you should give it a listen. I heard it this morning when I logged in, and it was pretty sweet. You should definitely check it out if you're at all interested in Linux operating systems, open source software that goes with it, like actually kind of all the tools we use these days.
We're talking about all the free and open source software that you use, even if you don't realize you're using it. Somewhere along the lines in your day to day, there's open source software, ticking behind the scenes, even if you don't see it. So it is cool to look into that. And that was kind of a discussion we had early on when Jonathan had proposed this. Is obviously, like you said, Hackaday is hardware, but I feel like the line is getting blurrier every day, and even if you look at the kind of projects we cover, it's getting rare anymore to find a purely hardware thing. Not to abuse the should have used a 555, but unless they are literally using discrete components and ICs, it's almost certainly going to have some kind of firmware, which is going to use some kind of open source library and was probably written, with an open source tool chain. So you can't escape software, even if you feel you're deep in the hardware camp. At some point, you're going to need to use software, and increasingly, it's going to be open source, which is cool, right? Like, that's not a complaint. So I think it's really cool, kind of extension of our wheelhouse, and especially with how long running it is, just to be able to keep it going. And I think 2006 is the first episode, which honestly I didn't even know they were doing podcasts in 2006.
Right?
Maybe they just mailed you a tape or something. I don't know. I'm trying to think, did I even have? Yeah, I must have.
Carrier pigeon comes to you by RSS.
It's really cool that we can keep it going, and wish Jonathan a lot of luck with it, and excited to see where it heads.
I was actually a guest on the podcast long before this all happened, and I'm a little bit of an open source zealot, and it came out in this podcast exactly how much of an open source software zealot I am, because I think I don't use any closed source software for anything. Like, my phone runs open source software. I'm that guy, right? But then I started listing all the real tools I use. Like, even all the hardware related stuff I use is open source software, like KiCad, or like we're talking to each other right now. We're recording this on Mumble, which is open source. I edit this podcast using Audacity and a bunch of open source plugins, FFmpeg. All the images you ever see on Hackaday are edited with GIMP. Hell, we're even hosted by WordPress. That's all open source.
Yeah.
Our entire server backend stuff is all running Git for the version control. I mean, like, there's nothing that isn't open source. And so I know I'm kind of on one end of a spectrum, probably the open sourcier end, but I only really realized when talking on basically a software podcast how much open source software I actually use, and that's like 100%.
Yeah, right. I mean, I think not necessarily all the contributors, but certainly I think all the editors of Hackaday are on Linux too, right? Or some permutation of a free operating system. So I think there's converging kind of mindsets there, though. If you're the kind of person who's hacking on hardware, I think inevitably at some point you're going to want the kind of freedom and flexibility that comes with open source, right? You know, even if you're not, like you said, not you don't think of yourself as like the open source guy.
Yeah.
You're going to come across a tool and it's probably going to be open, and you're going to use that, and you're like, well, this worked well, and let me plug it into another open source tool, and it just kind of happens. That's why it's called a viral license, right? It sneaks up on you.
Shall we head on over to What's That Sound?
This is a journey into sound.
What's that sound?
What's that sound?
This week is a y'all have guessed, let's see who got the right answer week.
Oh, good.
Well, you still have to listen and guess, Tom. You're not off the hook.
There's slightly less pressure. You know what? It's not less pressure. Just I get to learn right off the bat if I'm wrong. I don't have to
You get the answer straight up.
I don't have to think about it for a week. All right, let me listen to what we have here. It can't be that. Like my initial thought was like squeezing a plastic bottle, but that seems devious for what's that sound. Oh, is it a Rubik's Cube?
It is.
Oh,
Congratulations.
Yeah. Okay. Okay.
Hot diggity.
I was trying to that little clicky rapid noise. It unlocked a core memory for me.
Nice. All right. It was actually hard for Dan to hear it in the first time I played it, so I actually just picked up the very same Rubik's Cube and started turning it on my desk.
There you go.
And,
yeah.
That's what gave it to him.
It sounds a lot like munching chips or something. But I was like, no, I can't. You can't be sitting there eating chips and saying, "Oh yeah, go this sound." Yeah, what's that? What am I eating?
Well, things I am not doing include calculator button smashing, crinkling a water bottle. What else we got? Pencil sharpener? No. Opening an ESD bag. Ooh, that's a good one.
Oh yeah, I can see that.
Label maker. Man, I think some people just guess label maker every time, just hoping that they get there. Random keyboard. I mean, it does. I hear the keyboard sound in there too. I get it.
Oh yeah.
The Rubik's Cube guesses, however, not as many as I would have thought. A Rubik's Cube, exclamation point. More exclamation points make your answer more correct. 48 answers, of them 13 are correct. So lucky number 13. I have a 12-sided die. Well, I'm going to have to do something else. Let's see what the NIST has for us. NIST randomness beacon. This is a random number they generate every minute, and it's actually chained to the previous one through a hash. So it creates a verifiable time-stamped series of random numbers in case you ever need to agree on something in the future based on this random outcome.
That's a big red warning that says do not use beacon-generated values as secret cryptographic keys.
Yeah, because everybody in the world sees them.
Like, please do not do this.
They're the absolute opposite of... I mean, they're completely random. They're entirely random, but they're the completely opposite of secret. And the number is 8.
I feel like 8 has been the random number.
8 is always our random number.
Times.
It's a good random number. I picked it random once. It's still random.
Yeah, right?
I mean, you guys can all verify it. This is the NIST random number beacon. I just have to tell you its serial number, and you'll figure out that it's 8. Grep pulse index.
Someone should write a post on this.
I have.
This sounds like the kind of thing I'd like to read about on Hackaday.
Well, if you doubt my 8 as my random number, you can head on over to NIST randomness beacon. Pull down pulse 600657, which was the time when I hit the button, take the random number you get out, do it modulo 13, and you should get 8.
Hope they appreciate how serious we take the random selection of winners.
I do too. Oh yeah, right. So somebody won. Hold up.
That's why we started this.
So congratulations to Daddy Longlegs from San Francisco. You guessed a Rubik's Cube with an exclamation point. It was the exclamation point that pushed you over the edge.
There you go.
Congratulations. Consolations go out to our other correct answers. Boy, some whose names I won't say. Turbo Ferret. Bitmash. Mr. Orange. Congratulations. Can I peel the stickers? That's a good one for this one. If you didn't win this week, stay tuned next week for another sound and your chance to guess, get it right, and then the following week, get your name drawn and a Hackaday podcast t-shirt sent to you. Well, I'd like to start off the hacks this week with reverse engineering the Stadia controller Bluetooth switching procedure. This is a hack from Gary of the Google Stadia, which was basically a game controller that worked over web or Bluetooth or whatever, but Google's got a Google and they're shutting down the website that for whatever reason this game controller, I guess it was to play online games, right? It was to play games streamed to your home.
Right, it streams it to you. And so the hook was that the controller talked directly to their servers instead of having to go through like an intermediary on your computer. Like in theory, it was a good idea, but you know, like you said, Google's got a Google.
But then they shut their server down, and that's no good. They did do you the nice favor of letting you switch it one last time into Bluetooth mode. And I think you've got until the end of December to do it, but then they may be keeping their server up for another year after that. So you may even have until the end of December next year to switch your Stadia over to Bluetooth mode. But if you did, you could never switch it back to Wi-Fi mode, which may sound like it's no good, but maybe you wanted to play around with Wi-Fi mode. Maybe someone else will come up with a server that uses it, et cetera, et cetera. So this kind of one way you're now bricking the device did not sit well with Gary, who decided to figure out if he could flash the firmware to the device. And, well, I guess we wouldn't be here if the answer were no.
Right. That'd be a downer. And no. Moving on.
Sucks to you, throw it in the trash can. No, it's fantastic. So quick before the website goes dark, he tried to figure out how its entire firmware flashing routine goes. So he logs into the Bluetooth mode website that flashes the code over it to turn it into Bluetooth mode, Wiresharks it, and discovers how it gets switched into OEM mode, how it gets put into bootloader. Once it's in bootloader, how it enters this more sophisticated flash loader, how it detects the MCU type and sends the code across and then flashes the firmware. That's good enough. But armed with this, he discovered that he could take the read chip ID number command that the Bluetooth uploading website was using and change it to the neighboring reads the flash contents command. And so he iterates through this a whole bunch of times, 4 bytes at a time, and manages to download the old firmware, that is the Wi-Fi firmware that's sitting on his Stadia. And he's now got a copy of the Wi-Fi firmware and can still upgrade it to the Bluetooth firmware, and has completely man in the middle the conversation between the Google servers and his Stadia device. And so he wrote himself the Stadia tool, which is also linked here. You can check out his GitHub if you want to run it, and that will let you upload whatever the heck software onto your Stadia you want. And right now he's got the old Wi-Fi firmware straight off of his, and the Bluetooth firmware, he's going to start reverse engineering it. So that is super, super cool. I don't know. It's nice to see that you could take a piece of hardware like this that otherwise is getting bricked by a company that won't give you video games as a service anymore and keep it out of the trash.
First of all, it's classic Google, right?
Yeah,
right? They came out with this thing, and I wrote up a thing like when they announced the service was winding down, but they were giving these things out like candy. Like I have one, and just because I got an email and it was like, hey, you want one of these things? Like, yeah, okay. Because, it was a gateway into one of their services, and they figured, okay, we'll just send out a bunch of these controllers and hook them that way. You can use it plugged in, but otherwise, like, all it could do was Stadia, right? So they figured, okay, we'll give these things out, and it's a one-trick gadget. Of course, they'll pay for the service, except, that second part didn't happen, right? So there's like untold number of these things out there, and the idea that they were all going to be basically garbage sucked and was very unfortunate. So at first it wasn't even sure that Google was going to bother to release the Bluetooth firmware. Like there was kind of some begging and pleading on the community side even to get that much. But to see that the potential for further development, and now people are pulling the firmware off and exploring those avenues, is very exciting. I mean, the controller itself, you wouldn't think it because it's a controller, right? But like we said, it actually connected to the internet itself, and it sent the stuff to the data center. So it isn't a regular controller. It's a pretty beefy piece of hardware that could certainly stand to have some custom firmware development. I mean, there was an argument that like it's powerful enough to emulate some systems on its own. If you could figure out how to get
cool.
like video out or something, it could be like a little all-in-one emulation device. It's not just a dumb input gadget, in other words, right? So I'm really looking forward to hopefully more development along these lines and seeing what other tricks you can pull off with it. But just the fact that they're saved from the landfill is at least a happy ending, because it really could have went the other way. And it was like the router Google had for a while that just said, we're done. We're not doing this anymore. Or, what the Nexus Q, and like there's so many weird Google gadgets over the years that they just, end up in that big Google heaven. So it's cool that this one has seemingly escaped that fate.
This is first steps, right? This is get the firmware off and have a look at it. But now we've got a copy of the firmware and a way to reliably flash it. That is, the door is open.
Well, from hacking Google's sort of Bluetooth controller to other Bluetooth devices, I picked this story up, The Dark Side of Hacking Christmas Lights, literally. And this is about Will Cook, who apparently has a habit of picking up Bluetooth-controlled anything and sniffing the protocol and adding it to his smart home setup, which, hey, I'm not one to
Sounds
judge,
good to
right?
me.
There's worse things you could do with your free time. It's Christmas time, so every store is running these specials. He's found these super cheap Bluetooth-controlled RGB LEDs, and he grabs them and makes pretty short work of reverse engineering the protocol, which, is an interesting thing on its own. I really like these stories, even though we've seen it so many times. It even mentions that in there. Once you've reversed engineered one Bluetooth gadget, it's pretty much the same for all of them. But it never stops being entertaining to me. I really like that the workflow is always sort of the same, because Android, if you go into the development settings, will let you log the Bluetooth packets to file, which then Wireshark can read. So like all these stories start with, get an Android phone, put it in development mode, download the app, hit a bunch of buttons, then run that through Wireshark. Like this is definitely how this works. Like it's kind of a solved problem. Like if you have a weirdo app controlled Bluetooth thing, this is how you reverse it, right? So I always like to see that process. So that's half of it. So it was a success story in that regard. But then once he has kind of the command set, he knows how to turn it on and off and change the colors and change the modes, he starts kind of poking around, right? Because the app only let you do certain things, and there was like a mode parameter that would get different lighting effects. He's going through them, and he discovers like an undocumented mode that looks cool. Ooh, this is great. Hits that variable again to go to a new mode, and it just shuts off. So he's like, all right, they must have, that's where the logic in the firmware must have ended. And once you got past that number, it doesn't know what to do. So he restarts the thing, it pulls the power, and it is no more. And the closest thing he can tell, and it doesn't seem like there's been like an autopsy yet, although we're hopeful. It seems like maybe he just kind of like he just like overflowed a variable, and the firmware just corrupted itself or something. It just, it fell over so badly that now it can't even get back up. He said like, he powers it on, and it doesn't even show up as a Bluetooth device or anything. Like, it is well and truly done. So whether it's like it's stuck in some kind of a weird software limbo, or it wrote over its own firmware, who knows? I mean, I think the thing was like $2, so can't get too upset. The good news is that the LED strip itself is still like a regular addressable strip. So he says, I can just hack off the little Bluetooth module and wire it up to whatever, so not a whole lot is lost here, but part success story, but part cautionary tale.
I love how he ends it with, tell me how I can break my own lights, and sends you over to his GitHub.
Yeah, you too can break your own cheapy lights.
Where he's like, here's how it doesn't work. Send it this code and it'll brick. That's too funny. I wonder what's going on. Like, it really, you wouldn't think that things would be that easily overwritable in like a flash programmed, whatever it is, Harvard or von Neumann, I can never remember which, architecture device should be safe from this mess. I wonder if he, like when you send 12, it puts it in programming mode and it's like ready to receive new firmware or something.
This could be like the Stadia's controller mode, right? Like he's inadvertently made it ready to upload a new firmware. I mean, that'd be kind of a cool discovery. I think at this point it's kind of an open question, right?
So set effect number 11, and it seems to go extra bright. Set effect number 12, bootloader mode. Good luck getting it out.
Yeah, now that you mention this, it's not the most unreasonable thing I ever heard, right?
No.
That'd be the really cool end to the story. Like, not only was he able to figure out the protocol, find a hidden mode, he also figured out how to upload his own firmware, or maybe just broke
I
it.
got my fingers crossed for him, but like you said, at the end of the day, if he has to cut it apart and it's a normal RGB, addressable RGB LED strip, then he's still stoked.
It would be kind of cool to get another one and see, could you pull the firmware image off first, then put it into bad mode and see what the difference was. I mean, it would be an interesting. If anybody's looking to spend another $3, oh, no, $7. Oh, it's big money.
Oof.
But if you want to spend another $7 and get one of these things off AliExpress, I promise you, we'll put it up on Hackaday.
Well, my next story is absolutely not a hack. This is NASA's tech demo streams first video from deep space via laser. The joke here is that they were doing a test of this like deep space laser communication system, and they needed something that had a lot of bandwidth, and they wanted to tax the system. They sent a cat video. So this is like absolute record optical transmission, 19 million miles. They're getting a 267 megabits per second link, which is like a million times better than my home internet, with a one-way latency of just 101 seconds. And they did this to send a cat video of a cat taters chasing a laser pointer. Yeah, so that's kind of silly. And as Maya wrote, although the potential for space-based cat videos cannot be underestimated, ... And I'll finish it because this is an absolutely absurd and trivial test video. But this test of space laser data communications is nothing less than heroic and dead serious engineering, and an absolute miracle that they pulled it off at all. And to give you a little context for this, this is using a near infrared laser, and they're kind of blinking it on and off and hitting a telescope on the Earth. Telescope on the Earth reads the light and sends it back. Actually, they've got another sensor on Psyche, which is the space probe, which is actually going out to the asteroid by the same name. Going to figure out if it has an iron core. You should check out the Psyche mission by itself. It's actually pretty darn cool. But it's got a it's got a receiver on it as well. Both of these receivers are detectors for single photons, because that's how little light is making it across this distance, because they're shooting with a 4-watt near infrared laser. And, normally you think of a laser beam as being a little, pencil lead kind of thin thing. But of course, they have divergence, and by the time this beam gets to the Earth, it is about 2,000 kilometers wide. And so this is a 4-watt laser beam that's spread out to a spot that is 2,000 kilometers in diameter. So there's not a whole hell of a lot of light left by the time it gets here, which explains why they're using this giant 5-meter telescope at Palomar to receive it. But still, they have to have this incredibly sensitive, superconducting single photon detector thing to receive the signal from out there. So yeah, like cat videos, yes, but they are recreating, essentially it's almost like on-off keying what they're using, but then they don't get every photon that's sent from the Psyche deep space communications experiment. They're only getting a couple of these photons back. And so there's actually a whole bunch of statistical processing they have to do to figure out, based on the arrival times of these different photons, whether it's likely, you get 2 of them close together, you're like, well, that was probably an on. You get one now and you get a photon later. Was that period in between an off? Or is it just that you got unlucky and you didn't get photons during that period of time? This is crazy science. And I would like to say kudos to the Deep Space Optical Communications team. This is really seriously hard. And the goal, of course, is to have high bandwidth communications out to, say, Mars, basically. And that's kind of what they're aiming at testing for. They're not that far away yet. They're kind of only 80 times further than the moon out right now, but they'll get out there and keep on testing as they go. Whoa, amazing.
As they go is kind of the key thing, because this is, from reading the article, it doesn't sound like a one-time thing. They're going to keep doing this farther and farther out, and it talks about potentially being able to do this from as far out as Jupiter's orbit, which is pretty far out there.
That's cool.
Way farther than we're going. Anytime soon. It's like, this is one of those things that we don't really need it now, but like NASA wants to have it in the back pocket so that when the time comes, they'll have the technology. Psyche doesn't even have like a camera or anything on it that would require this much bandwidth. Like, this is purely, like, they had to preload the cat video. Not that there would be many cats out at that distance anyway, but like it wasn't like they were recording something and needed to send it back to Earth. Like, they brought this from home with the intent of sending it back. Obviously higher bandwidth is going to be transformative for a lot of future missions, not just the 4K boots on the ground video that they're hoping for. Talk about like New Horizons when it went past Pluto.
Right.
Now we're past Pluto, and like for the next month or whatever, it was going to be sending the data back, because like it couldn't do it at any kind of proper speed. It was this little drip of all the data and images. So there's always this kind of concern that your probe has captured some awesome data, but then you have to wait so long to get it that maybe something could happen. Space is a dangerous, unforgiving place. So you imagine like you finally captured that piece of data you've been waiting your whole career for, and it's going to take a month to send it back to Earth, and that's when the thing goes belly up, right? So being able to send data back quickly and reliably is super important. And they've tested like optical links from the space station too. Like, this is definitely the shape of things that come.
Yeah, but the space station is easy. The space station's just like, it's right up there. I can even see it at night.
Yeah, I can see it.
Like,
they just hold a
hella
flashlight
far
out the window.
away. And yeah, and their bandwidth will drop as they get further out.
Oh,
they actually
sure. Yeah.
they actually did this test. They ramped it up. So they have different transmission modes where they, dwell longer on the on periods and the off periods essentially. And, they tested it at a lower bit rate, and then they kept ramping it up until they couldn't get any more clean video across, and they got it at least up to 267. I don't know if that was the last good value or not, actually. But my guess is as it gets further and further out, of course, that spot's going to get bigger, fewer photons are going to hit. They're just going to have to lower the bit rate to keep it up out of the noise floor, and that's just the way life is. I said that the spot was 2,000 kilometers wide by the time it got to us. But like, the Earth is cruising along relative to the spaceship, and they actually have to lead the Earth a little bit from its apparent position on the Psyche to hit it. Because by the time the beam gets to the Earth has moved on in its orbit. They have to have a special stabilizer for the laser on Psyche, even though this thing is silent running in the dark space of our solar system. There's still too much vibration. So they have to have this like extra vibration canceling unit on the laser itself so that they can point it accurately enough to hit the Earth, which they say is like hitting a dime from a mile away, and a dime that's moving and, of course, wiggling. And yeah, anyway. Whew.
And with the bureaucracy of NASA and how long this has to be, like, think of how long they've been planning this cat video meme. Like, this is years in the making. They're like, I know just what we're gonna do. Get the press release ready.
It's good press release. I'll give you that. They give good press release.
Got people talking about it.
For our folks, it's like totally burying the lead.
Well, on to slightly more terrestrial technology. This one's called Old Prius Gets Upgraded Batteries, and I thought this was really kind of fascinating. I'm sure the Prius aficionados in the audience will be upset, but I had no idea that literally until like this model year, or like the 2023 model year, Priuses were using nickel metal hydride batteries, which
What?
I just assumed they would have been lithium, right? Because everything in the world is lithium, and I also forget how old the Prius is. I think
Yeah.
this article said like the first one in the U.S. was like 97 or something, which is like, all right, I get back then they'd be using hydride, but I'm very surprised that even to the modern 2020s they were still using what we would consider now like an antiquated, like imagine if somebody was like, I got a new phone, like, oh cool, what kind of battery does it have? They're like, oh, it's got nickel metal hydride in it, right?
That's not nickel cadmium.
Yeah, right. Yeah, like I got the old NiCad phone, but still, what we would certainly consider very antiquated battery tech, especially when everybody else, all the electrics are moving over to lithium, is kind of a weird holdout. Ignoring whatever technical reasons they went with that, we now have better stuff, right? So there is apparently a unofficial community developed upgrade for Priuses. I don't know if all of them, but going back at least towards the older ones, and they seem to have pretty good coverage over the years, where you could swap out the old pack for a new lithium one, right? And there's kind of a trick there because they aren't reprogramming like the car's onboard controller or the battery management system or anything, right? Like you can't make the car aware of the new lithium batteries, so you have to trick it a little bit. Like there's some onboard circuitry that basically says, everything is fine. I am standard nickel metal hydride. Please do not be alarmed. To make the car calm down and use these things. So that kind of constrains the performance a little bit from what I was reading. Like they can't really use all the benefit of the lithium because the car just doesn't know how to do it, right? Like charge rates and stuff are kind of set in the ECU, and there be dragons if you're going to try to reprogram that. But if you have one of these Priuses where the battery's dead, right, and you don't have anything to lose, then it makes sense to get one of these lithium packs and replace it instead of going to Toyota and saying, hey, send me, because they will. I mean, they'll sell you a new nickel metal hydride pack that you can put in there, but this for like $2,000 to $5,000, it looks like, depending on which battery pack your Prius had, is a kind of a compelling option because you get the newer battery chemistry and all the benefits that comes with. And they do talk about there is a little bit of a performance increase because they do a deeper discharge and that kind of thing. It's kind of shocking how small the Prius battery pack is. We're used to seeing stuff like the Tesla, where like the whole undercarriage is basically a giant battery, right? But that's an electric car. It needs a lot of capacity. These hybrids, were really only meant to run the electric motor at low speeds, when you're pulling away from a stop sign and stuff. So it doesn't need anywhere near that kind of capacity. And when they pull the battery out in this the video here, it's like, I think they say it's like 80 pounds. It's the kind of thing where like they just pick it up. There's no lift or anything that has to like slowly lower this giant battery. They just say, okay, they take the back seat out, like, and they pull this battery out by hand. It's big, but it's probably only maybe twice or maybe 3 times the size of like a traditional 12-volt car battery. Really is kind of surprising with a modern eye anyway, how small these batteries were. But
I was astounded by how small the battery was in the Prius. Like you say, it's a 1.3 kilowatt hour battery.
Maybe we could have dwelled longer on the hybrids before we went all in on full electrics, because if just such a small pack in the back of the car, can increase the, they're talking like 50, 60 miles to a gallon. Once you average it all out, I mean, that's a hell of an improvement for a battery pack big enough that you could just heft by hand, right? So,
right.
It does kind of make you wonder, like, maybe we should have been doing more of this for longer. But hey, everybody wants the all electrics. They're the new hotness.
I'll let you in on a secret that I don't think any of our commenters noticed. I don't think Brian Cockfield, who wrote this, noticed. I go look at this original article linked in here. Check out the byline. It's written by Hackaday's own Lewin Day. who is our
Damn you, Lewin Day. Look at that.
Lewin is kind of our resident car gearhead, and he also writes for a couple other outlets, as far as I know. This is the Autopian, which I'd never heard of. He also writes for the Drive, and here we are. We stumbled on Lewin in the wild, so kudos to you, man.
If there's an automotive story out there, he's usually on it.
All right, well, my last long hack this week is multi-view wire art meets generative AI. And this is a research paper by a team from the University of Surrey, among others. This is a really, really cool idea. I guess I first encountered it in the cover of the book for Gödel, Escher, Bach. Right? There's that, it's a cube and it's cut out so that when you cast light on it, the shadow on one side is a G, the other side is an E, and then the other dimension is a B. That's a really cute trick. Here, what they're doing is using bent wire to do the same kind of shadow depends on which direction you project at it from trick. Except they're using a computer and in particular one of these AI algorithms to do the line bending. And, they're not making these in the physical world yet, which came up in the comments. And some of the angles look really hard to do. And it looks a little bit scratchily. But what they are nonetheless doing is creating a single solid line that if you cast a shadow on it from 3 different directions would give you kind of arbitrary pictures. They are also doing AI image generation on the front, but the really cool thing they're doing is using it to pick where the lines all go. And that's actually really interesting here, and they do it in a particularly clever way. And I think to understand how clever it is, you need to know a little bit about these diffusion image generation models. Like this is how Stable Diffusion and DALL-E and all them work. These diffusion models work like this. They train them on images and then make the images noisier and noisier and noisier by adding random noise to them. And then they train the neural network to kind of predict these transitions from the original image to a noisier and noisier version. And then they run it backwards when they want to generate an image. They start with noise and they say, okay, now give me something that looks more like a tiger. Now give me something that looks even more like a tiger and more like a tiger. And so the network is kind of picking the most tiger-like features out of this pile of random noise to begin with. In this paper, instead of starting out with random noise, they're starting out with a random bunch of Bezier curves. And that's really neat because they have a small number of degrees of freedom. You have these control points and endpoints, and that kind of draws a curve in space. Except they're not starting off with a single one. They're starting off with a whole pile of spaghetti. And basically, the parameters that the model's been trained on isn't random noise pixels to image pixels, but instead are Bezier control points to the shadow looks like Iron Man. And so they're doing the same kind of diffusion trick, except not over a pixel space, over a parameters of Bezier curve space. And that's essentially the gimmick here. It's really clever. They also have to take these multiple curves and have all their endpoints hook up with each other. So they've got a loss function in there that, makes sure the lines all hook up at the end. But this is just such a crazy application of this diffusion neural network idea, algorithm, formula, that I really love it. And they point out that there is previous work in this, not in the 3D wire art space, but in 2D space, where people are doing, again, Bezier curve-based image generation, and those sound super interesting to me. If you are at all interested in this, you should check out this paper or go directly and check out Bezier Sketch and or Vector Fusion. They're both doing the same kind of thing, but on a more general, making a drawing type problem space. Anyway, really, really neat stuff, and not the kind of, I don't know, in my mind, overhyped large language model type AI stuff, but actually taking a really, I think, interesting, cool problem and solving it using a particularly clever method.
That sounds like somebody should make a website about doing that.
Yeah, right?
Find a way to do it maybe once a day.
If it weren't an academic paper, it would almost be a hack.
I like in the comments, people are immediately were saying, okay, now do it with real wires. You know, get something that really bends the wires or, laser etches it into a cube or something. I think it is a method that's begging for some kind of a physical manifestation because it doesn't look really cool. And you would think easy is not the word to use, but, there's certainly some kind of path towards taking these line coordinates and making them into the physical world.
Oh, I'm down with that. I want to see it.
I don't know why, but I love Caption America. I know it was just simple spelling mistake in the
Simple
images,
typo.
but it just really captured the imagination of the commenters. Caption America is going to be the unofficial hero of Hackaday from now on.
And the best is they give this poor AI Spider-Man, Iron Man, and Caption America, and it comes up with the right answer anyway. In 3D,
Yeah, there you go. That's
bent
AI.
wire. I mean, come on now.
Somebody posted in the comments a link to like an open SCAD thing. Did you play with that? I don't know.
Does it work with arbitrary letters? Oh, maybe it does. Let's find out.
Oh, that's cool. So you lines up with the.
Oh,
Well, that's pretty fast
good.
rendering too. For if it's worth doing, you can do it in open SCAD.
This is true. And even if it's not.
We'll find you a library anyway. Well, this last one is Raspberry Pi Zero Power's custom camera platform, and I was really taken by this one. We've seen quite a few custom cameras. For most people, the camera that's already in your pocket is going to be fine. Average, hey, I gotta take pictures of the kids, and it's holidays, and do our group shot. I mean, your phone is more than adequate for that kind of thing. So the market for cameras for non-professional use has certainly gotten smaller and smaller over the years, right? I would say at this point, unless you're a professional or really into the hobby of taking pictures, you probably don't have a camera anymore. You probably just have your phone, right? But at the same time, it's been kind of interesting because the technology available to us in terms of sensors and single board computers and modular stuff has made it easier than ever to make your own camera. So this kind of disconnect where fewer people need them, but now it's easier to make them, right? So we're starting to see these custom digital cameras that are really a labor of love because let's be real, it's going to be tough to build a better camera than what you already have in your phone. But that doesn't mean you couldn't make a camera that has more, let's say, flexibility, right? And more of an artistic potential to it. Because in the case of this one, they're actually using the Pi HQ camera module, which means you can put proper lens on it, and with a lens comes all sorts of artistic stuff that you could do and depth of focus, and it's a bigger sensor, so it lets more light in. So right off the bat, having that Pi HQ camera module does offer some cool possibilities. Since it's hooked up to a Raspberry Pi, you have complete software freedom to do anything you want. And the easy thing would just be to capture a raw image and then do whatever your post processing is on the desktop. But of course, there's all kinds of cool stuff that can be done in software on the camera itself. If you were so inclined, you can imagine time lapse that you could build right into the software and that sort of thing. So it's exciting to see these kind of DIY camera platforms develop, and I do call them platforms because especially this one from Jacob Cunningham. It's very early days. This is not, and that's not a knock on the project at all. I mean, but this is not the kind of thing you're taking to Christmas this year. You know what I mean? These are very early days, and while the hardware itself is close, it's a little boxy, but it's certainly got all the necessary features, right? The buttons and the ergonomics. The software is almost non-existent, and this is something that's still kind of being developed. We were just talking about this. Still changes getting pushed to the Git as we're talking about it, right? So the software is happening right now. When I actually wrote about this one when I went on the site, and I think it was at version 0.0.0.1, and I don't even know that there was a menu. Actually, I think it just came up on the screen, and now there a menu system is being formulated and icons and stuff like that. So we're watching this kind of DIY open source camera be born in real time, which is always fascinating to me. if you've ever been interested in like the finer art of photography and pushing things a little bit farther than the camera in your phone can go, but you don't want to necessarily fork out for an expensive professional camera. I mean, this is an interesting kind of in between where you can get some of those capabilities with in terms of like interchangeable lenses and more capable software, but you don't have to break the bank. And there's the added bonus that, you can build the thing yourself and make it to your own kind of specifications. So I think it's definitely a very exciting time for those who are into photography in this like new post-film, post-camera age, right? We're almost post everything at this point. We're going back to the old days with camera obscuras, but with Raspberry Pis inside of them.
I'm gonna be that guy. I'm the guy who has a real camera, and I have a real camera because I like real lenses. And I'm not 100% sure that these CCTV camera lenses are actually quote real lenses.
Well, better than not having one, at least, right?
But it depends on what you're comparing it to, right? It's not a crappy piece of plastic. It's a lens meant to take some images with some glass in it. So at least I got to give that up. Anyway, cool project, and stoked to see what you can do with it. I think turning it into a normal camera is like half of the potential here, but then, you've got image processing on board. You've got a computer to do timing or multiple exposures or who knows what else. Like stopping at this is a camera that takes snapshots and not going all the way to this is a camera that does slit scan effects digitally or, other crazy crap. I can't see it. I think this has to be pushed forward. Well, my first quick hack is Zachary Tong's Up Close and Personal with a MEMS microphone. And this is really cool. Zachary over at Breaking Tap's YouTube channel takes a scanning electron microscope, looks inside a MEMS microphone, and if it weren't etched on silicon and hyper tiny, you would say it's just a normal microphone. The membrane is made out of silicon, it's dimpled for sure, but it's suspended over another piece of silicon. It bends a little bit and it deflects when hit by sound waves. It's a microphone, just a tiny microphone. Next up, Trent M. Wyatt's Arduino measures remaining battery power with 0 components and no I/O pin. This is an old trick, but he's made it into a nice library called CPU Volt. The idea is a lot of microcontrollers have a voltage reference source on board. So you take a reading with the ADC, which goes from 0 to VCC. You read how the band gap voltage falls in this, and from that, you can infer what the VCC value is. It's an old trick, but it's a great trick to have in your pocket. If you don't know it already, go check out his library, CPU Volt. And last up, the hot chocolate effect explained is a video by the Action Lab. I know this is the cappuccino effect. When you go bonk, bonk, bonk on the bottom of your frothy beverage of choice, it makes in the case of cappuccino, a kind of nice deep sounding tone. In the case of his freshly poured hot water, it's a little bit higher. But what's weird is as it degasses or as the milk foam pops, the pitch rises upwards. And he goes through explaining why it is that this happens. The answer is that the whole fluid is vibrating. And when it has a lot more air dissolved in it, speed of sound in air is slower than it is in water. It runs at a lower pitch when it's got more air in it and a higher pitch as the little tiny air bubbles dissipate into the atmosphere.
Well, for my first quick hack, I've got Storage Media Forgotten, which is pretty straightforward. This is a video from This Does Not Compute about a storage media that is forgotten. In this case, it is the Avatar Shark. I certainly haven't heard of the Avatar Shark, and Al Williams, who wrote the piece, hadn't heard about it. So the chance that you and the audience haven't heard about it is pretty slim. If Al Williams doesn't know about it, it might as well not exist. Kind of like a zip disk is sort of the impression I got. 250 megabyte cartridge. They were like $40 a disc. The drive was 200 to 300, depending on what part of the 90s you were buying it in. on paper it looks cool. It physically looks kind of cool too. Actually, it's a neat like physical format. You can kind of see the platter inside. Like it's got like this conformal case, which is kind of interesting. The reason that you haven't heard of it and nobody used it is one, it seems like Avatar was not a brand that anybody wanted to give hundreds of dollars to in the 90s because they weren't as well known as iOmega and the other companies out there. And the other problem is apparently that the discs could not transport very well. And it says that if you tried to go somewhere with the drive, with a disk loaded into the drive, it was probably going to damage it and you're going to lose some data. So things we can't even imagine today. Get 32 gigs onto a flash drive, throw it into a bag and don't think about it. But back in the day in the 90s, you had to worry about your 200 megabyte disk being corrupted if you walked too fast. Next up is how a Lego set is born, and this one is particularly fascinating to me. Lego, since I think 2008 or somewhere around then, has had a thing where people could submit ideas. It's like a little democratic process. If you get like 10,000 people to vote for your idea, they'll look into it. They won't guarantee you they can make it, but they'll look into it. They figure if they got 10,000 people interested, it's enough. This project particularly was to create a Lego Polaroid one-step camera, and it was super successful. It got all the votes necessary to go, and it looks like now it's going to be, or already is in production. Like this one went through. The interesting story here, though, is that The Verge has an article that kind of walks through the whole process. It's one thing to just come up with an idea and show that it can be made out of Legos. Lego as a company still has to get the rights to do it and figure out how to package it and how to write the instructions. And there's a lot to happen to take a one-off Lego creation and make it something that can actually be on store shelves and built by people. So I thought it was really interesting to look into the process that I hadn't seen before. Lego has like this internal BrickCAD program that they use, and there are unofficial ones out there that you can download that say, okay, you need Lego piece XYZ or whatever, but this one that they use internally is tied into their whole production mechanism, so they could make a design with it and say, oh, okay, well, it needs these parts, which is also parts that we have in the Star Wars speeder kit or whatever, so they'd be able to like cross-reference it and figure out how many other kits use these parts and what it will cost them to put into production and that kind of stuff. So a lot of cool, if you're into Lego and the behind the scenes thing, it's a very cool write-up. And finally, the small and silly synth, now even smaller, but just as silly. This is a really, really cool project from Mixella. It uses the cheap CH32 microcontroller that we've been seeing more and more over the last year or two. It uses a little buzzer and a USB-C connector and not a whole lot else. I mean, the result is like this maybe thumbnail-sized little USB-C gadget that you can plug in, and it receives MIDI and will basically just make a little beeping noise. One of them would just be annoying, but if you have a bunch of them and you plug them into your USB hub and have them set up properly, it can do a really cool little desktop chiptune thing. So it's interesting from a hardware standpoint. The PCB design is super impressive for how small it is and everything that's packed in there, and it sounds pretty cool in the end too. It looks like the intent is not to distribute these things and to make just make them for fun, but I think I would buy one. So if they ever go on sale, I'm down for at least like 4 or 5 so I can play chip tunes live at my desk.
All right, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I'm picking Lewin Day's Ask Hackaday, what do you do when you can't solder? I guess some people in the comments interpreted this as unable to solder because they were like, well, just freaking learn to solder, man. It's not a big deal.
Yeah, right?
But the idea was to go through a lot of the funny alternatives to soldering that are out there, including those like solder seal connectors, which kind of look like shrink tube, but with solder and flux inside them. And so you hit them with enough heat to melt it and they make a butt splice for you. There are, crimps. You could do the 2-sided crimps where you put them into basically a metal tube and you squish down on it hard enough. There are those funny ones. I guess they're called Scotch lock or press lock. You have a small metal guillotine or something that bites through the insulation and locks over in plastic. I love Lewin's comment in the caption to that one. If you find these in a car's wiring harness, buy a different car. Because they have a habit of wiggling loose and they don't hold very well. And then finally, he mentions the kind of ever present here in Germany, but I hadn't seen them much growing up in the States, the Vago connectors, or Wago or Wago, or however you people pronounce them, connectors, which, like I said, they're everywhere here, and they make them both in kind of a lever lock version and another one which just kind of has a angled, springy pieces of copper, and so you stick your wire in there and it kind of just wedges in and it gets a good grip on them. Those have the advantage of putting the wire under tension. Like there's actually a spring pushing on it, so there's like a constant force on it. Unlike those other funny ones, I guess if you do a crimp and you do it well, it's actually the metal itself is compressed enough and that provides the spring force. But like those Scotch lock / press lock ones, man, they're just gonna let go on you. Missing in this article, because Lewin is an Aussie, I guess, are wire nuts. And that is
Yeah, right.
kind of what the American equivalent of the Vago connector is, the wire nut. And I don't know, they get a bad rep, but I always thought wire nuts, when done right, were pretty awesome. If you get the right size one, you can screw it on down there, and it actually, the inside of a wire nut, it's angled in, right? So it's like it's tapered. And so if you get the wire in there just right, and you can really crank down on it, that's almost as good as a crimp in my book. Fight me.
Yeah, well, the doing it right is the tricky part. Getting the right size and actually getting it,
Yeah.
tight up in there.
I don't
But,
think
yeah.
I've ever done it right. But
Someone out there must have done it right. This is a really interesting one, and I agree. Like, I think there was a lot of knee-jerk reactions to the title. I'm like, of course I can solder. Why can't I solder? I'm on Hackaday. It's not, like I said, not just a matter of skill of solder. There are times where soldering might not be reasonable, or
I'm not going to solder the ceiling lamp to my house's wiring, right? Like, what am I going to do there?
yeah, there are times where even the most portable of iron is not really making sense. And of course, a lot of them, and like we said with Lewin, he's got a very automotive kind of bent. Like, if you're out in the driveway, hooking something up in the car, you probably aren't going to be soldering it. I mean, you could, but more than likely you're going to be doing one of these kind of splices or something. Not not the little crimpy the press lock ones. I did get a laugh out of that too. If you see this by a different car, because they are like the hallmark of aftermarket alarm systems. They're just hanging on for dear life. But some of these other methods are a little bit more legit, and I haven't used them personally, but like you said, the one with the heat shrink and like the band of solder in there are at least really interesting. I think Big Clive did a video, and if I recall, he came away relatively impressed. It was the kind of thing like, if you're on your back under the dashboard of your car and you're trying to hook something up, the ease of being able to just slide this on there and hit it with the hot air gun, you're gonna be glad, right? Like it's worth it. It might be, this isn't something you necessarily use on the workbench, but if there's a time and place for it, it's better than some of the other options out there. And I think that's what the takeaway is. That there's a time and place for everything. Who is it? The Russians don't solder. The Russians only crimp, like on fighter jets and stuff. They don't use soldered joints for the idea that they can vibrate and snap or whatever. So it's easy to say, oh, I'll just solder it, or But if all you got is a hammer, everything looks like a nail. It's the same kind of thing. Like, there are other methods, and you should be aware of them, because you might find that it gets you out of a jam or prevent you from being in a jam in the first place.
And of course, this being an Ask Hackaday, the comments are just full of good other solutions. I guess Lewin somehow slept on terminal strips. Those ones that terminal blocks, the ones that have the screw downy things. And of course, as soon as I said connecting the lights to your home wiring, that's what we have over here on basically everything. So yeah, those. A lot of these solutions are for house wiring, but what if you're doing like electrical component wiring? And of course, there's always wire wrap. Why do we always forget wire wrap? Because I've never done it. Have you?
No.
I need to try wire wrap someday. Some of those old geezers definitely swear by it. And I've seen people who know what they're doing with wire wrap do it. And it's actually pretty quick. You do need those funny posts that have they have these pins that you wire wrap to, and they're definitely four-sided, and they definitely have four sharp edges. And that's actually important to cut through the insulation when you wrap it around. So you can't just go, I'm going to wire wrap this to that. You have to have wire wrap pins to do it. But that's one of those things. We should have a wire wrap competition next Hackaday
Ooh.
SuperCon. We'll bring out the wire wrap and
Yeah, right.
see who's old school.
Yeah, forget the SMD challenge.
That's right.
It's too easy. They're getting too fast anyway. We gotta give them something new to do. Well, my pick is also a Lewin Day article. We're coming up all Lewin today. This one is parachute drops are still a viable solution for data recovery from high altitude missions. So don't say that too quick. To get this one, you have to kind of roll back the clock a little bit, which, Lewin does in the beginning, but there was a brief-ish time in the 50s into, I guess, early 60s where we knew how to put satellites into orbit to spy on the Soviets and, anyone else we wanted to look at. But we didn't have the technology to reliably send digital images over the air. So early spy satellites had to literally take a picture and then send the film canister back down to Earth in a little capsule that would re-enter the atmosphere, pop a parachute, and you didn't want this thing to fall into the wrong hands, so a lot of times they were caught midair, so they wouldn't potentially get snapped up by the Ruskies or something. And it was this kind of Rube Goldberg period where the technology was kind of out of sync, right? We had the ability to put a spacecraft in orbit, but not a picture. So we had to make do. Now, obviously, that's not a problem, and satellites don't have to drop film canisters anymore, but it turns out that the concept is not wholly without merit, and that brings us to NASA's SuperBit telescope. And this was a telescope that was on a high-altitude balloon launched from New Zealand, and it spent month plus in the upper atmosphere in space-ish like conditions taking pictures. And the primary way of getting the images off it was SpaceX's Starlink, and then it also had a backup through the NASA's Tracking Data Relay satellite system. But the Starlink dish failed, apparently. The TDRSS link was unstable. So when your primary and secondaries fail, where are you left with? And it turns out they had a system on board where they would literally just drop the data off. It's not a film canister, as you might imagine. It's actually a Raspberry Pi with a bunch of SD card writers and its own power supply on this little circuit board that goes into a roughly bomb-looking kind of contraption. And it comes complete with a servo and a little arm to unhook itself from the mothership. And they just free fall down, and there's a little zero insertion force Ethernet connection, looks like, that would allow the Pi on the data bomb unit to communicate with the telescope and copy things over the network, but could be broken at a moment's notice when it commanded the little mechanism to let go of the cable and drop. And apparently they dropped a couple of these things with 5 terabytes each on them. It wasn't like they couldn't have got the data off otherwise, but this was a convenient way of doing it. And much like sending a cat picture from Psyche, this is kind of a test for a system that could be deployed on multiple other missions. A lot of times when NASA does work, they like to use it as much as possible, right? If you can spend all this money and time developing something, we can at least use it more than once. So the idea here is that this kind of modular data parachuting thing could be popping up on other NASA projects in the future. I can't at the moment think of other applications for it because, usually they're a little bit farther away than a balloon. But hey, if they have other high altitude balloons or maybe drones, or, they're doing long duration flights, there'll be a need to drop off these data cartridges in the future. So it's a cool, like, everything old is new again story, because it's a very similar idea to what they were doing in the early days, but with a modern spin. And it was cool to see a legit Raspberry Pi just bolted to the side of this thing. No gussying it up or anything. Like, NASA don't have any time for that kind of thing. They just bolted a Pi to it, put a 9-volt battery in it, and dropped it from a balloon. That's all you need. Why overcomplicate it?
That's what I love about this, is it looks so much like a hacker project. Like, this looks like something we would have done with my Hackerspace's high altitude balloon project. And, it's not that far from it, except it's done right. I mean, it's a couple servo motors that open these tethers. It's a Raspberry Pi. It's a friggin' 9-volt battery, on the thing. It is funny that way, but think about it. It's a great way to store all that data. It's dirt cheap, and these things are floating up there doing multiple orbits of the Earth, but it's in a balloon, so you don't really get to choose where it goes. And I love the strategy here of kind of every time we fly over South Argentina, we drop one of these so that we at least get some of the footage down, right, in case the worst happens. And that's pretty cool too. Like, if you have a couple of these systems up there and you can drop them, you'll at least get something out of it. Even if you later, stratosphere goes the wrong way, the balloon ends up lost at sea and it sinks deep into the ocean forever. That would be a bummer if all the data went with it, right? And so this way you can at least get yourself a little bit out. And I think that's pretty sweet. But yeah, I think this is a great crossover project. It looks like something a high altitude balloon enthusiast community could have made. But it's also something that the high altitude balloon community could look at and be like, ooh, I like the way they did those tether releases, for instance, which I really do. Or, clever use of that zero insertion force socket so that it's powered by the main battery until it lets go. Or, there's a bunch of really cool things they did here in addition. So totally cool, both because it's low tech, high tech, but also it's high tech, low tech.
Oh, there's a GitHub for this thing. Oh, it's all here. Yep, the whole thing is here.
Yeah. Where is it?
And guess what? They did the 3D work in OpenSCAD. Man,
see,
these guys are right after my own heart. So that all the 3D printed cases, OpenSCAD. Very nice.
Where is this? Where's this GitHub? Show me the link.
Everyone listening is like, I want to see the link too. Show me.
Send everybody in the listeners the link too. Don't be stingy.
Yes, we will definitely put this in the show notes. It looks like maybe an earlier version, maybe. Oh no, it just doesn't have the Pi mounted, so it looks a little weird.
Still work in progress, but more complete than it was. I hear you, man. I hear you.
Oh, it's a archery release. Oh, that's what the thing is too. Oh, that's cool.
Oh, right.
That's a cool detail.
Sure.
So the little wire thing, because I was looking at it, I was like, that looks very custom. It's an archery, like when they do like the high performance bows and you don't want to actually do it with your fingers. They have the little hand clips. That's what they're using to let go of the tether. Oh, that's cool. Thank you, NASA, for making all your stuff. I mean, we paid for it, so.
That's right.
I suppose they have to, but yeah, this has got everything in it. PCB files. Man. Oh, well, that's awesome. It even gives you the part number for the parachute. I can get one free shipping within the USA. 2 or 3 day order. Well, I know what I'm doing. Imagine that. Imagine doing science with public money and sharing all the information so others can benefit. What a novel idea.
What? Just like you should. Yeah. That's it for this week's Hackaday podcast. Thank you all very much for listening. If you want to check out the links, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, send us a line, tips@hackaday.com. And until next week,
keep on hacking.
Whew.
I showed it to my wife and she was like, why is it a teddy bear? I was like, it's not a teddy bear. It's funny because to me, I'm like, I wish the keyboard was loud.
Elliot can hardly even hear it over in Germany. The Google Stadia Stadia, the Google.
Proper segue and everything.
Hell yeah.
Old Prius gets update. Those aren't the words. Sorry, dying real quick. God, am I being bombed? Why is it so?
Let's see.
Well, for my okay.
If you want to head on, doing some Bluetooth hacks, and no, this is not gonna work.
They should figure it out now.
This is episode 248. This is episode 249.
Caption America.